Hello students and welcome to the course Urban Rail Transit Tracks, Stations and Yards. By now we have learned that the forces from moving trains is distributed by the rails, fastening systems, and sleepers. In this lesson, let's keep moving to see track bed, which passes the distributed forces onto the foundations. A track bed, also known as a railway bed or roadbed, is a foundational structure on which a railway track or railroad is built. The history of the track bed is closely tied to the development of the railways and the evolution of transportation infrastructure. In the early stage, sleepers with iron rails were directly laid on the ground, which made it impossible for vehicles to move fast. As railways evolved, more advanced track bed construction techniques were developed. These include using track ballast. Track ballast is a layer of broken stone, gravel, or any other granular materials placed and packed below and around the sleepers for distributing load from the sleepers to the formation. Meanwhile, the track ballast provides a stable base for the tracks, allowing them to maintain their alignment and resist movement under the weight of passing trains. The ballast also helps to absorb some of the impact and the vibration caused by trains, reducing wear and tear on the tracks and the rolling stock. Track ballast can also provide the drainage as well as longitudinal and lateral stability to the track. The voids between the stones allow rainwater to drain away from the tracks, preventing water from pooling and potentially causing damage to the tracks or subgrade. The ballast also helps to prevent vegetation from growing up around the tracks, which could obstruct the view of train operators and cause safety issues. The ballast in railway tracks serves various crucial functions. It provides a sturdy base for sleepers, secure their positions during their passages, evenly spread the loads, enhances ride comfort by offering flexibility, ensures stability, aids drainage, and helps maintain the track's alignment and level. The size and the quality of the track ballast can vary depending on the variety of factors, including the weight and the speed of the trains, the climate and soil conditions in the areas, and the local regulations and standards. Now, let's discuss different types of ballast materials and their specifications. Sand ballast is used primarily for cast iron pots. It is also used with wooden and steel through sleepers in areas where traffic density is very low. Coarse sand is preferred in comparison to fine sand. Sand ballast offers several advantages for railway tracks, including excellent drainage capabilities, suitability for cast iron sleepers without generating noise during train travel, and its cost effectiveness as they are readily available at low cost. However, there are notable drawbacks to using sand ballast as well. It can be prone to blowing off easily due to train vibration or strong winds, necessitating frequent renewal. Additionally, the friction created by sand can lead to excessive wear on sleepers and moving parts of the track, which can increase maintenance requirements. The decomposition of laterite results in the formation of marram. It is red and sometimes yellow in color. The marram ballast is normally used as an initial ballast in newer construction and also a sub-ballast. As it prevents water from percolating into the formation, it is also used as a blanketing material for black cotton soil. Marram ballast offers some advantages, particularly when used as a sub-ballast, especially in areas with weak soil subgrades. Additionally, it contributes to the visual aesthetics of the track. However, marram ballast has notable drawbacks. It is quite soft and it tends to return in a powdery substance that can blow away when subjected to vibrations, necessitating frequent maintenance. Due to its vulnerability and degradation and limited durability, marram ballast is typically not recommended unless no other suitable materials are available for railway track construction. Core ash ballast has several benefits for railway track construction, including its economic affordability, abundant availability, excellent drainage properties, and ease of handling due to the lightweight nature. However, there are notable drawbacks associated with core ash ballast. When subjected to loads, it tends to turn into dust, making the track dirty and complicating maintenance procedures. Additionally, it is not recommended for use with steel sleepers due to its corrosive action, which can affect both with sleepers and rails, leading to the increased maintenance and potential structural issues. Broken stone ballast is most commonly used on railways, which present various benefits on railway tracks. Its inherent hardness, toughness, and durability make it a suitable choice for securing sleepers and maintaining track stability, especially on high-traffic and high-speed rail lines. Moreover, its long-lasting properties contribute to the cost-effectiveness over time, reducing maintenance requirements. However, certain drawbacks should be noted. The initial cost may be relatively high due to the limited availability of the broken stones. Additionally, train passage over its ballast generates noise, and its sharp angular edges can pose a risk to wooden sleepers, potentially causing damage. Gravel is naturally occurring material formed by the erosion of rocks. They are suitable for all types of sleepers and are usually round and smooth and can be obtained from riverbeds, gravel pits, etc. Gravel ballast brings several advantages to railway tracks. Being on the natural resources, it is cost-effective and easily accessible. When properly cleaned, it offers excellent drainage capabilities, reducing the risk of water-related track issues. Moreover, compacted gravel requires less maintenance and exhibits high durability, contributing to its long-term cost-effectiveness. However, there are certain drawbacks to consider. The smooth, rounded nature of gravel particles can result in their separation from the track bed due to the vibrations. Naturally occurring gravel may contain earth or clay, necessitating thorough cleaning to maintain its drainage properties. Sieving is also required to eliminate small gravel particles that could affect the drainage. Lastly, the use of the gravel ballast can generate noise when trains traverse a track, which may be a concern in noise-sensitive areas. The size and shape of ballast materials can vary, but practical experience shows that they need to meet the following criteria. First, they must be tough and resistant to wear to withstand the constant pressure of moving trains. The hardness should be enough to prevent it from being crushed under heavy loads, and the generally cubical shape with sharp edges could enhance its stability. Non-porosity is crucial as it should not absorb water, which could weaken the track over time. Moreover, it should resist both attrition and abrasion, maintaining its integrity amidst wear and tear. Durability is of utmost importance, ensuring it remains intact even in adverse weather conditions. Efficient drainage properties are necessary to prevent water buildup, and cost-effectiveness is a key factor, making it an economical choice for railway construction and maintenance. Therefore, track ballasts nowadays are typically made from crushed rocks or gravels, although other materials may also be used. The general problem which occurs with the ballasted track is the slow deterioration of ballast materials due to the traffic loading. Ballast consists of packed loose granular materials of which the grains wander, wear, and break up, causing increasing geometrical unevenness and clogging of the ballast bed by fine particles which cause drainage problems. Therefore, regular maintenance is time after time needed to restore the track alignment. Okay, in this lesson, we explore the critical role of track beds in supporting railway tracks and distributing loads effectively. We discussed the various types of ballasted materials, including sand, mortar, coal ash, broken stone, and gravel, each with its advantages and drawbacks. We highlighted the importance of selecting durable, hard, and non-porous materials that offers efficient drainage and cost-effectiveness. Regular maintenance is crucial to address ballast deterioration and maintain track alignment, ensuring the safe and efficient operation of railway tracks. In our next lesson, we'll dive further into the intricacies of railway infrastructure and the vital components that keep the train rolling smoothly. See you next time as we continue our journey through the world of urban rail transit.